Hello all. The topic of presentation is design and simulation of square wave generator. In this practical, we will design the square wave generator for given specification. We will observe the output voltage waveform as well as the waveform across the timing capacitor, and then we will calculate the frequency as well as the amplitude of output voltage. The circuit diagram for square wave generator will be given. It uses the positive feedback through resistance R1 and R2, and it uses the negative feedback through resistance R and C. The capacitor will be charged and discharged through the resistor R. The specifications are: we will assume VCC is equal to 12 volt and VE is equal to minus 12 volt. We will design the square wave generator which can generate the square wave of the frequency 1 kHz. For that, we will assume the value of timing capacitor C is equal to 0.01 microfarad. The formula for output frequency is given, and if in that formula if we assume R1 is equal to 1.16 R2, then F0 will be 1 upon 2 RC. So if F0 is 1 kHz and C is 0.01, then the value of R will be calculated as 50 kilo ohm. As R1 is equal to 1.16 R2, we will assume R2 is equal to 10K and R1 is equal to 11.6 kilo ohm. The feedback network gain beta is calculated as R2 upon R1 plus R2, which is equal to 0.46. The V saturation value will be 0.9 VCC. That's why plus minus V saturation is equal to plus minus 10.8 volt. The charging and discharging of capacitor will be between plus minus beta V saturation. So it will be equal to 4.97 volt. We will build a circuit and then we will simulate the circuit and we will validate our theoretical result with the practical result. The circuit has been built. R1 is 11.6 kilo ohm, R2 is equal to 10 kilo ohm, R is 50 kilo ohm, and capacitor value is 0.01 microfarad. We have connected the measurement probe at the input across the capacitor as well as the output. I will simulate and will get the charging and discharging of capacitor is between 10.6 volt, whereas the output voltage is plus minus V saturation is equal to 22.2 volt and output frequency is equal to 926 Hz. If you double click on the CRO, you can easily observe the waveform. This triangular waveform is nothing but it is the charging and discharging of the capacitor. There is a difference between triangular wave and charging and discharging of capacitor. There is a slope, some curve in the charging and discharging of the capacitor. Now if you select the cursor, you can directly measure V peak to peak voltage like this. The peak to peak voltage will be 22.2 volt. That's why plus V saturation is equal to 11.1 volt and minus V saturation is minus 11.1 volt. If you click on triangular wave, then select the cursor like this, then you can directly measure the charging and discharging of the capacitor, which is equal to 5.2 volt and minus 5.2 volt. So this is how we can calculate the we can calculate the V saturation, minus V saturation, plus beta V saturation, minus beta V saturation and H0, and we can validate our theoretical result with the practical result. Thank you.